Hello everyone, I am Mopali Chakraborty. I am going to present our work, Flexible Metasurface QR Code for Identification and Sensing, from the Bendable Electronics and Sensing Technology Group, University of Glasgow. The authors are Hatem, Matbouly, Pablo, Escobedo, and Ravinder, Dahiya. The barcode or QR code is an optical label that contains the information about the item to which it is attached. The information is read optically by an optical reader. In this work, we have presented a new approach of using QR code as a metasurface for sensing and identification by incorporating thermochromic sensors into the QR code to simultaneously obtain the universal product code as well as the physical parameter. Now coming to the design and principle of operation, in our approach, two main sections of the QR code are the finder pattern and the separators. In the finder pattern, there are three identical structures located in the three corners of the QR code. It enables the decoder software to recognize the QR code. Another section is the separator, which have a width of 1 pixel, and they improve the recognizability of the finder pattern. For the proposed QR code sensor, the colorimetric physical temperature sensors are integrated in this finder pattern section. Next is the Metasurface QR code sensor. Thermochromic and photochromatic papers are integrated at the three finder pattern section. The change in color is evident when the QR code is placed on a top of the hot surface or top of the cold surface. The QR sensor level is visually detected by the smartphone camera. The color of each circle is processed separately to obtain the average color inside the square. A generic flowchart of the smartphone application is included in this figure 3A. When the user opens the app, there is a splash screen. Click on the open camera to take the photo of the QR code. After taking the photograph, the user needs to align the QR code to this white square. This masked image is then automatically processed on the smartphone. And upon processing, the app will generate a text-based report, which details is shown in this figure 3C. Currently, a CHT technique is used to detect the sensors. Some difficulties are also encountered for image processing in terms of false positive detection, as shown in this figure 4. So finally, we can conclude that a novel approach for simultaneous sensing and identification with thermochromic and photochromatic papers is presented to form a metasurface on the conventional QR code. It has the ability to sense ambient conditions as well as identify the type of product, which make it suitable application for such as food monitoring. The QR metasurface sensor is read by the smartphone camera, and then the results are analyzed using a developed app to detect the color variation of the physical sensor. This system can easily be adopted for another physical parameters such as gases and humidity by replacing the thermochromic papers by other functional materials. The system can be further improved by testing different approaches to optimize the image recognition algorithm. This work was supported by the EPSRC Fellowship for Growth and the Newcomb project. Thanks for listening.